Welcome to the today's video lecture series. Today the unit 3 we are going to see, that is the electric propulsion system and the motor control system. The electric propulsion system means with help of electric motor the vehicle is driving forward on the road. So which comes under the course outcome 3 to exemplify the electric propulsion system and motor controlling techniques, under which the learning outcome 1 is to discuss about the electric propulsion system, under which the specific outcome 1 is to explain the construction and working principle of DC motor. So we know that there are the various types of DC motors, or the various types of motors are available for driving the electric and hybrid vehicles. They are the DC motors, DC series motor, permanent magnet brushless DC motor, permanent magnet synchronous motor, three-phase induction motor and switched reluctance motor. All these motors are preferably with the high starting torque to be used in the electric and hybrid vehicles. So today we are going to see about the DC motor constructional details with help of its diagram. So this is a DC motor constructional diagram. So the outermost part is said to be the field yoke or the magnetic frame. So here the stator is said to be the field coils or a field windings are said to be the stator, and rotor is said to be the armature winding or the armature coil. So this is the stator core and this is the rotor core. So the entire parts of the DC motor has been covered by means of the yoke, otherwise this is said to be the magnetic frame. And the field core consists of the field coils, whereas the armature core consists of the armature coils. So this is a shaft through which it has been connected with the mechanical load, and the field core the field coils are having, and to the armature core the armature coils are having. The field core and the armature core are made up of the cast iron or the cast steel, and this is said to be the pole axis. And the armature windings, these are all said to be the slots inside which the armature coils have been housed effectively. So this is what about the constructional parts. Here there is this is said to be the pole shoe. This area is said to be the pole shoe. So this is a poles. This is a magnetic poles of the electric motor. So inside which on which the field coils are wounded, and this area is said to be the pole, and this bent part is said to be the pole shoe, which is said to be the pole face also. Next. So we will see about the yoke. So the purpose of the yoke is to cover all the inner parts of the electric motor, and also to protect from its mechanical damages. This yoke or a magnetic frame is made up of the cast iron for the smaller machine by considering its cheapness, whereas for the larger machine it is made up of the silicon or a rolled steel in order to provide the high reliability. So the important functions of the magnetic frame or the yoke is to provide the mechanical support to the magnetic poles of the stator of the electric motor, and to provide the protection from the dust, moisture and various gases to the whole or entire motor, and also to carry the magnetic flux produced by the magnetic poles of the electric motor. Next, so this is said to be the pole shoe and the pole core. So this area is said to be the pole core. This bent portion is said to be the pole shoe of the electric motor. So the pole core, that means this part, is made up of the cast iron or the cast steel, which is used to perfectly reduce the eddy current losses. So eddy current means it is a DC current produced in the metal when it is placed in the magnetic field. So the functions of these poles are to provide the magnetic flux whenever the field winding is excited with the DC supply. So next, so the purpose of the pole shoe. The pole shoe is made up of the cast iron or the cast steel. The pole shoe is used to reduce the reluctance of the magnetic path, and also this pole shoe is used to spread out the magnetic flux lines in the air gap. Next, so the field windings. We know that the windings means it is a coil. It is made up of a copper material which has a very good conductivity. So which is wounded on the pole core, that is said to be the field coils or field windings. We are usually connected in series, and when the current passes through it, the pole gets magnetized. And field winding is made up of a conducting material, as I told earlier, that is copper or aluminum, because they are having the good current carrying capacity. So this is a field winding. So the field winding is wounded on the pole core, and it is connected one after the another with the armature coil or armature winding. Hence they are said to be connected in series. So this is a series field coil because they are connected one after the another with the armature coil or armature winding. So this is said to be the field winding of the DC motor. So the field windings or the field coils wound on the field core of the electric motor. Next, so the armature core. The armature core, we know that it will be in the cylindrical shape, and this is placed between the field poles and the motor shaft. So this armature coil will be wounded on the armature core of the DC electric motor. So this has a high permeability, low reluctance material like a iron or a cast steel. So which uses a high permeability, low reluctance material like cast iron or a cast steel. So they are also provided with the lamination coated within the thin films to reduce the losses due to the eddy current, and also this lamination provides the mechanical security to the armature winding. Next, so this is the armature core of the DC motor, which is made up of the cast iron or the cast steel, and this is said to be the armature winding, which is wounded on the armature core of the DC motor, and this is a commutator which is mounted on the shaft of the DC motor, whose function is to convert the bidirectional AC supply, I mean bidirectional AC current, into the unidirectional DC current. So bearing to avoid the friction loss and sound, we are using the bearings, and the shaft, it is used to be connected with the mechanical load. So the armature core, it provides a low reluctance path produced by the field coils or field windings, which is wounded on the poles of the DC motor. And this armature core, always it houses the armature conductor. This armature core is made up of the materials like the cast iron or the cast steel. So this is an armature core or armature winding of a DC motor, which has slots through which the armature coils have been housed, and these windings are wounded on the armature core of the DC motor. This is said to be the commutator mounted on the shaft to convert the bidirectional AC current into the unidirectional DC current. Next, the armature winding, we know that it acting as a rotor, so hence it is rotating inside the magnetic field produced by the field windings. So it is a current carrying conductor armature winding which is placed in the magnetic field produced by the field windings. Next, so armature winding or armature conductor can be connected in series with the field winding in order to increase the voltage. Suppose if we want to increase the current, means this armature winding is connected in parallel with the field winding. So they are categorized into two types, lap winding and wave winding. In case of lap winding, a number of poles is equal to the number of parallel paths. In the case of the wave winding, number of parallel paths is constantly fixed as 2. So this is a commutator, so which is also cylindrical in nature, and it converts the bidirectional AC current into the unidirectional DC current, which will be mounted on the shaft of the electric motor, so which is made up of the insulating materials like a mica. Next, so the function of the commutator, as I already told, converts alternating current or a voltage into the direct current, and this can be extracted from the brushes. Next, so these are all said to be the brushes. As this electric motor has been concerned, these brushes are used to feed the electrical supply or electrical input to the electric motor, whereas in case of generator it extract the electrical output current from the generator, but here motor it feeds a input as a electrical supply through this brushes only. So these brushes are made up of the carbon or a graphite material which are rectangular in shapes. So we used to collect the current from this brushes via the commutator, and it is applied to the external load if it is a generator. In case of motor, we can supply the electric current via the brushes. So it is another meaning is that it ensures the electrical connection between the rotating commutator on the shaft of the motor and the stationary external load circuit. So that's all about the constructional parts and the constructional idea of the DC motors. I hope that you would be understood. Thank you.